My name is Eric Killens. I'm the sales manager here at Granite State Solar. To give you a little bit of background about myself as well as the company, Granite State Solar was founded in 2008. We're headquartered in Bow, New Hampshire. I've been with the company since 2015. I started with Granite State Solar as a solar advisor, so doing outside selling. I was the one going out to people's homes and businesses and educating them on solar energy, evaluating their house for solar, designing their system, and sending them a proposal, going through that whole sales cycle with that customer in hopes that they would go solar. So today my presentation is going to be more about Solar 101, the kind of layman's terms of solar, high-level terminology, and we'll talk a little bit about net metering, and of course, like Mark mentioned, the benefits and advantages of why you should go solar. So first slide's pretty obvious. Why solar? Solar is an abundant, affordable, and accessible source of energy. Pretty obvious there, right? It's abundant, meaning that every day the sun rises. No matter whether it's sunny or cloudy, there is usable energy hitting the Earth's surface. I have a solar system at my house. Personally, I've had it installed since 2017. And like Karen alluded to, as well as Mark, every solar system typically has a monitoring system. So you can monitor the energy output of your solar array on a daily, weekly, monthly, yearly basis. I've found that even on a cloudy day, although you don't have direct sunlight hitting the earth and there's not direct sunlight hitting those solar panels, you are generating energy to power your house on those days. Solar energy is also very affordable. Like Mark said, there's different buying options or purchasing options with solar. You can either purchase the system directly through your own means of funding. You could finance the system, or you could do a lease option. In the last decade, in my experience, the cost of going solar in terms of cost per watt has gone down considerably. That price decrease over the last 10 years is mainly driven because of a decrease in price materials, from the actual manufacturing of the solar panel to the inverters that are underneath those solar panels to the rail and racking system that those solar panels lay on. In addition to the decrease in material costs, there has been a substantial efficiency increase in how the installation is done. Couple that with, again, the ability to finance a system if you don't have the means to pay for it outright, makes it even easier to go solar. Of course, the last one, accessible. That's pretty given. No matter where you are on the earth, everyone has access to the sun's energy. So very high level, again, types of solar energy. There's passive solar systems and then active solar systems, right? Passive solar systems are the ones where there's a structure, the materials used, the placement of the building are all optimized to try and harness as much of the sun's energy as possible. An example of a passive solar building were the ones built in like the 70s and the 80s, when honestly the cost per watt of a solar panel was extremely expensive. It wasn't very economical to put in solar photovoltaic on your roof. So the way that people were able to take advantage of the sun was positioning their house to the south. The south is where you're going to harness the most amount of energy. Sometimes those homes had, say, on the first floor, the floor was made out of concrete. That's a heat sink. During the winter time, the sun would filter through the windows. That floor would warm up, and at night, that floor would slowly disperse energy throughout the home. That's a passive solar type of technology. On the other hand, there's also active solar. Active solar are systems where that energy is converted into more usable forms, such as solar thermal, or what we install, solar photovoltaic panels. The picture in the middle is an example of a solar thermal system where you have tubes on your roof, and those tubes are filled with glycol. The sun's energy warms up that glycol, and that glycol typically gets plumbed down into your basement, and that is what is able to heat your domestic hot water in your house. Again, that was a form of solar energy that was used when the PV was still pretty expensive. You don't typically see solar thermals being installed anymore. Most of the active solar is just your traditional solar photovoltaic panels. When customers come to us and say, hey, how can I still get my hot water from the sun? Our typical response is, well, there's great, really efficient electric water heaters called heat pump water heaters that are powered off electricity. So we say, install some more solar photovoltaic on your roof that produces electricity that then can power that heat pump water heater. So this slide talks about the three main solar systems. Again, Grand State Solar, we only install solar photovoltaic. The most common one that we install is a grid connected or net metered solar system. What that means is you're going to have solar panels on your roof or on the ground, and you're still going to be connected to the utility company. So every month you're still going to be receiving an electric bill like you normally have been. The big difference is that when you go solar, the utility company swaps out your meter and they install what's called a net meter or a bidirectional meter. And what that meter is going to be doing is it's going to be spinning in two directions. It's going to spin backwards, and it's also going to spin forwards. So on sunny days, like Karen was talking about, when her solar system is producing more electricity than what her house needs, the excess energy is going to flow back to the utility company, and that's when her meter would spin backwards. She's going to be getting credits from the utility company when that happens. On the contrary, if at night when the solar is not producing and she's still pulling power, her meter spins forwards and she's purchasing power from the grid. So effectively, that meter is keeping track of the amount of purchases of kilowatt hours from the grid and the amount of sales of kilowatt hours to the grid. So on a monthly basis, your utility will read that meter. They're going to see how much power you've sold to them and then how much power you've purchased from them, and then simply bill you. On a seasonal basis, in the spring and summer, the spring and summer months are the months where you have longer daylight hours, you in general have sunnier weather. So as Karen and myself and Mark noticed in on our monitoring systems and on our bills, those are the months when you are overproducing. So your solar system is producing an abundance of electricity month over month. And what you're doing is you're effectively building up this credit on your electric bill. And that credit is then intended to be used in the wintertime now when you have shorter daylight hours, there's snow on your solar panels and they're not producing for you. The analogy that I kind of like to use is if people heat their homes with wood, what are you going to do in the spring and the summer? You're going to chop down a tree, you're going to buck it, you're going to split it, and you're going to let it sit there and cure. And then in the wintertime, you take from all of your cords of wood to heat your house. The nice thing with going solar is you don't have to have any manual labor to do that. The next system that we install, which is getting more and more common, is still grid-tied. It's still net metered, but it involves a battery. The big advantage of having system number 2 is that a battery is going to give you backup means of power in the sense that if you have system 1 and the grid goes down, it's a winter storm and you lose power from your utility, per code, your solar panels also have to shut down. They can't produce for you when the grid is down. There's a safety mechanism in place that basically has a relay in the system. And if your solar panels aren't sensing grid power, they can't produce. Because the utility company doesn't want you sending electricity back out to their grid when the linemen are trying to work and restore the power. So that's the really big benefit of a battery, is that you can keep your solar panels to continue to produce when the power goes out, and you can effectively have an endless supply of power during an outage, so long as that there's sun during the day, whether that be a full sunny day or even a cloudy day. that those solar panels are going to recharge your battery, and then you're going to use that battery through the night. System number 3 is an off-grid system. Effectively with that, you have cut the wires from the utility company. You are not net metering. You are relying solely on your solar panels, a battery, and maybe even a backup source generator for your electricity needs. System number 3 is very uncommon. We don't do them. But for people that live in remote places where it might take or cost hundreds of thousands of dollars to bring utility lines to that property, an off-grid solution might be the system for them. So the types of solar installations, there's 2 main types. There's roof mounted as well as fixed ground mounted. Granite State Solar, we do both of them. On a roof mount system, you have to think about the roof material. So we typically install on three main roof types. That's asphalt shingle, standing seam metal, and corrugated metal. And then on the fixed ground mount systems, again, the system is going to be anchored to the ground using ground screws. We don't use any type of concrete. In general, we have to put the fixed ground mount in an area that's typically relatively level. You know, you can't be putting this ground mount on a hill that is sloping severely from east to west. In the picture like you see there, it needs to be relatively of a flat space, open space, of course, that gets good sun. This slide talks about what makes a good roof for solar. Granite State Solar, we are very, very big on, again, educating the customer on solar and making sure that solar is a right fit for your property. So what we're looking for when we go out to a customer's house to evaluate whether solar is right for them is we look at 2 main factors. If they're looking at a roof mount system, we're looking at orientation. Orientation, or azimuth, is the direction that your roof faces. That's a big determining factor about how much electricity your panels are going to be producing for you. So of course we're here in the northern hemisphere, right? We want to be facing as south as possible to produce the most amount of electricity off your solar panels. The more east or west facing your roof is, the less productive your system's going to be and the less electricity you're going to produce. Doesn't mean you can't go solar. We just have to factor that into our design and the estimate. The other big determining factor is access or solar exposure. That determines for you and for us how much sunlight your panels are going to be receiving on an annual basis. If you're going to go with a roof mount system, we also look at the age of the roof. You know, age of the roof, if you have an asphalt shingle roof, is really, really important. We as Granite State Solar, we're always looking out for the customer's best interest. We're not going to install on an asphalt shingle roof that's 20 years old. The reason being is a solar system typically has a 25-year warranty to it with a lifespan of around 40 years. Well, if you put that long of an investment on your roof on an already 20-year-old infrastructure, more than likely you're going to have to then take off your solar panels, take off the racking, take off all the wiring to put on a new roof. That's going to be extra cost for you. We don't want to have you do that. So we typically say that if your roof is 15 years or older, you should really consider talking to a roofer, seeing how much more life you have on that roof before you go solar. Material, we already talked about that. Standing seam, asphalt shingle, corrugated metal are the 3 main roofing types that we install on. Ideally, you know, if you had to choose one of those 3 materials to put solar on, standing seam metal would be your best bet. The reason being is you're not putting holes in your roof. All you're doing is you're clamping onto those seams. So it's the least intrusive way of doing the install for a roof mount system. But that's not negating or dismissing an asphalt shingle roof or a corrugated metal roof. We primarily actually install on asphalt shingle, and that's because it's the most common type of roof around our area. Yes, you have to penetrate the roof, but I can tell you, being in the industry for a decade, that we have come a long ways in terms of the technology on how to mount to that asphalt shingle roof and how to make sure that that penetration has an air and watertight seal for the 25 years or longer that that system's going to be up there. So this slide talks about how to measure solar exposure or solar access on your roof or on the ground. Again, knowing what your solar access is a big determining factor about with how much electricity your system is going to produce for you. So we always want to come out to your house and do a solar estimate where we bring a device that will measure how much sunlight that roof receives. We used to use what's called the Solmetric SunEye, which is the device that you see on your left. That would measure your solar access. The downside to a tool like that is the solar advisor would have to get their ladder out, they'd have to get onto the roof, they'd have to get to the exact spot where those solar panels are going on the roof and take a reading to measure your solar exposure. It was an accurate way of doing it, but there's also safety concerns with doing it as well. Especially in the wintertime, you can't really get on the roof when there's snow. So we have transitioned to a newer technology. We use drones to do our solar estimates. And for each solar estimate that we do, we actually fly a drone up into the air. We do several orbits around the house, and those orbits are taking hundreds and hundreds of pictures during their 15 or 20-minute flight. And what we're doing is we're basically going to be importing those pictures into a software program, and it creates a 3D rendering of your house. And while it's creating that 3D rendering, so we can put the panels on your roof and get down to 1 to 2 inch accuracy of roof measurements, we're also getting LiDAR data, figuring out how tall those trees are that are surrounding your house. That software also knows the path of the sun for all 12 months of the year. So what it's effectively doing is when we put panels on your roof, we're actually getting down to the panel level solar exposure readings. It's one of the most accurate ways to provide an estimate for someone is to have someone come out to your house, fly a drone. And it's extremely important, I stress this, because you can get proposals from other companies that'll say you're going to generate this amount of electricity. How do you know that that's going to actually work for you? You need to make sure that people are doing their due diligence, that they're taking the time to provide you with an accurate quote, and really that's what Granite State Solar strives for, is giving you the most accurate quote that you can. System sizing. So in order to offset your electric bill, we need to know how much electricity you use. So what we typically ask for is we ask for a copy of a most recent electric bill. And that electric bill is going to show you the last 12 months of electric data in kilowatt hours. We look at that and then we say, all right, someone's been using 10,000 kilowatt hours. We know what the wattage of a solar panel is. We know how productive your roof is going to be. And we make a determining factor on how many panels you need to offset the last 12 months of usage. But I like to tell my customers that when sizing the system, let's talk about what you have been using for electricity and then what you might consider you will be using in the future. You know, we're in this era of electrification. Everything around us is getting electrified, from transportation to how we heat our domestic hot water to how we heat our homes. More homes are getting installed with electric heat pumps or mini splits. More people are driving plug-in hybrids or full-on electric vehicles. All of these things are adding to the consumption of energy. So I say let's design for the present, but also design for the future. Some of these things that you see on the slide here, like adding a heat pump or moving to an electric water heater, are all going to boost your electric bill. Well, if you're going to go solar once, add more panels now, so then when you start using more electricity, you still don't have that electric bill. This slide talks about the one main incentive right now that is available to people interested to go solar. I want to stress that this is a slide for people that are looking to purchase their system or finance it. It's a 30% tax credit that the person would be, or the system would be eligible for. That 30% tax credit is off of the gross system cost, and it is currently still valid through 2032. It covers both the cost of your solar system and also the cost of a battery if you decide to go with a battery as well. Vet your installer. So this slide, we have this on here because when we talk to customers, we actually encourage them to get multiple quotes. We say going solar is not a short-term investment, as Mark has alluded to. It's a long-term, high upfront purchase. You know, it's one of those purchases that could be more or one of the second most expensive purchase outside of buying your house. You know, because effectively what you're doing with solar is you're buying electricity for the next 25 plus years at one time. So we always say, you know, thank you for contacting Granite State Solar, but we encourage you to talk to others. And what we recommend you do is, number one, get multiple quotes. Check out their reviews online. How many reviews does that company have? What are customers saying about that company? How many years has that company been in business? That's really important because you're going solar for the long term, right? You want to make sure that you're partnering with a company that is going to be around for the future. If you ever need to have that system serviced, you don't want that company to be non-existent and now you're left in the dark about what to do. Another big thing is, do they perform on-site solar assessments? That goes back to your solar exposure readings. You want to make sure that this company is doing their due diligence and they're giving you an accurate system design. So for the first 1 to 2 years, you can look back at the estimate that they gave you, and that estimate is right in line with what that system's producing. You want to make sure that you understand their service commitment. Again, if you ever need to have your system serviced in the future, what does that service commitment look like for you? Then, of course, ask for local references. References are great people to contact to see what their experience was working with that company. So this slide talks about the 3 main benefits of going solar. Of course, the number one, there's a big economic benefit to go solar. When you purchase a system, you are effectively making an investment back into your house. You know, Zillow, the realtor website, says that on average, homes with solar sell for about 4% more than comparable homes that don't have solar. And I think, again, it goes back to we're in an era of electrification. I feel like the generation that is in grade school, high school now, when they are in the market to buy a house, there's going to be a lot more solar on homes that are going to be on the market. And they're going to have an electric vehicle. They're going to have a plug-in hybrid. And if they're purchasing a house that already has a source of generation on it, that's a really attractive thing. So I think even though, you know, you might have a 12-year return on investment with your solar system at your house, you're setting yourself up for a house that is going to sell well into the future, because I think that's just where we're heading. There's also a big environmental benefit to go solar. Obvious is that solar panels are emission-free. They don't pollute. And in the first around 3 years of the solar panel's life is when they become carbon neutral, meaning that it takes about 2 to 3 years for solar panels to be carbon neutral, where they produce enough electricity in the first couple of years to offset the electricity that it took to manufacture them. And of course, peace of mind. You know, it's nice knowing that you've bought electricity for the next 25 years, one time at one cost. So you're not subjected to that up and down electric rate that you get from your utility company. This slide just talks about the 3 main benefits of a battery backup if you decide to go that route when you are also buying your solar panels. Number one is peace of mind. Like I said, with a battery, when you lose power at the street, your solar panels can continue to produce for you during the day, and then that battery can discharge electricity to your house at night. They're also very reliable. In comparison to like a generator that is a whole house generator or even a portable generator, those types of backup systems have engines and motors that require maintenance. Most batteries, or almost all batteries these days, don't require any maintenance. And of course, batteries have a good, clean feel to them because the electricity that's in that battery, was generated from the sun. So those were my slides. And I think at this point, we are going to do a Q&A. So I'll put the mic down, and hopefully we have some questions. Yep.
Well, I have a question. The tax credit of 30%, is that in jeopardy now with the Trump administration? It's hard to know. No one knows. Okay.
Yeah, I think, so as administrations swing back and forth, one never knows what they're going to do. I think right now we probably really don't know what's going to happen because we have somebody who's at his side that is very involved in green energy, which is a really good thing. I think that they all recognize that about 250,000 jobs in the country are coming from green renewable energy, and part of that is because of the 30% tax credit. About 8 years ago, it was scheduled to go down from 30% to 26. It went to 26. It was going to go down to 22. And then the last administration brought it back up to 30 and locked it in for about till 2032, as Eric mentioned. There's nothing on the radar right now for it to go down. However, when somebody's considering a solar project, when you do the project is what tax credits you're eligible for. So if somebody was to start a project now and it's a 30% tax credit and they were installed within that 30% tax credit bracket, you're getting the 30% federal tax credit. So it's a really good time. I don't see it going up. I can say that. But it's a really good time to consider it because the tax credit is there right now.
Hi. So when I was talking to my wife about coming to the meeting, and this kind of goes to the point that your slides had about think ahead to future changes you'd make and install to provide for that. So like this isn't like a consultation for as a customer necessarily, but just sort of to get an idea of what things you'd consider. If we are, we don't get our heat from electricity like we get it from propane. So would obviously if everything in our house was already running off electricity, that'd be like the golden opportunity to get solar. But is there like a kind of a cutoff point where using just your only your power is hooked into electric and you have propane or you have gas heating or all these other things, is there a point where your advice would be think about upgrading to get more into electricity and then boom, you put it in? Or is it, you factor that in when you do the panels and then just say you were thinking of doing this in the future anyway, we can just take care of that now?
Yeah. So the way that we have those talks is we have to look at, also be realistic about it, right? If you're looking at a roof mount system and there's only so much roof space that you have, and if we design the initial system for you and that initial system covers your current load or what you've currently been using, well then right there we know that even if you add more electric things to your house, there's not a potential to put more solar on your roof. So on the opposite end of that spectrum, if you do have a large amount of roof surface and you could put enough panels to cover your current load and then additional panels our recommendation would be put the additional panels on your roof now when you're putting the initial system in, because there's economies of scale. And think about it as it's not a use it or lose it type of an investment, meaning that it goes back to net metering. If you put in a oversized system on day one and say the first year you drastically overproduce, that's fine. That extra production is going to be put on your electric bill as a credit. That credit stays with your electric account in perpetuity. So if you decide in 3 years to upgrade your propane heating system to electric, great. You'll do that, and then you'll have a big credit to use with your utility company when you start drawing more power.
Got it. So one of the limiting factors is really the only one is the size of the space, right? If you have too small of a roof, then it's not. You could think ahead to all these other electrical things, but like there's a point where it's not effective enough for you if you have a tiny roof.
Yeah.
But I guess that's not common. Like I think most people have like normal sized roofs, I guess.
Potentially. I mean, there's a lot of roof surface, but that roof is really cut up, right? You
Oh,
could
sure.
have roofs that have like a typical Cape style home with on the front there's dormers. Those triangular shaped dormers.
Right.
Those types of roof surfaces don't typically bode very well with solar because solar panels are rectangular shaped.
Right.
And that limits the number of panels that you can fit up there.
Got it.
Yeah.
Thank you.
Yep.
I'd also jump in and say one other quick thing that I don't know if I touched on enough before, but this is one of the interesting things one of my non-solar savvy friends thought was amazing. Another thing to consider is what probably the bigger variable other than the tax credit is what your utility company will allow. So what we're starting to see now is what they call complex reviews on transformers. And what that means is, let's say I wanted to put a 10 kilowatt system on my house, and the transformer will only allow me to put an 8 kilowatt system on my house. So what we have happen, people don't realize that the utility ultimately has that final say on what you can do on your house. So I have 4 right now that are in review, 3 in Massachusetts and 1 in New Hampshire, where we said, this is what we'd like to install for this customer. And the utility company came back to us and said, well, you're only allowed to do this. And that's it, period. They have to either go with 8 kilowatts or they get nothing. So if you can, and that's something that could change. And the utility companies are not really looking to invest more money in infrastructure that's not going to pay them back. So to Eric's point, if you have the opportunity and you definitely we're adding a hot tub or we're going to switch over to a heat pump instead of propane, it's definitely something you want. That's another reason you want to, kind of a hidden reason you want to consider doing a little bit more now. Because as he said, you're not going to lose the electricity, but you could lose the opportunity. If there are no other questions, do you have any questions for me?
No, I don't think so. I'm good. Oh, maybe Mad Dog has a question.
Not so much a question, but an observation. I'm actually in the process right now of doing 2 things in my house. Number 1, cutting down on the amount of electricity that I'm using, and number 2, looking to solar to produce the electricity I do use. So I have a well, I have propane heat, but I need electricity to make both of those work. And so I'm looking for electricity, solar, and a battery backup to give me more connectivity or continuity in case of a power outage. I could get a generator. I've looked into that. That would be about $9,000 right there for a generator to take care of my whole house. And even then, I have to be careful with what I would turn on. So I would use to try and cut down the amount of electricity I'm using to allow my battery to stay active and keep me going through the power outages that I have had in New England, sometimes up to 2 weeks. I know that's a long stretch even for solar, but I could try. So
Do you guys do smart panels? Yeah. Okay. Yep. So, in response to that, I would say, first of all, the battery technology, one of the hidden costs that people don't think of with generators is that if it's a propane or a gas generator, you have to feed it something. So there's an additional cost over the $9,000 that you have to feed it with power. And one of my friends out in Ringe had a really nice home generator, and 4 years ago we lost power. It was a really bad snowstorm, and his wife teaches from home and he works from home. And over the course of 4 days, with the loss of power, they went through $200 in 4 days in propane to run their house off of a propane generator. So there's another cost there. Something that both Eric and I also really encourage people to do if you're considering going with battery backup is what's called smart panels. Breaker panels, as we've known them for years and years and years, are just simply an on-off circuit. And now they're coming out with smart panels that on the surface, it looks like a regular breaker panel where you can turn things on and off. But you also, on an app, you can control what's happening on that panel, and you can even set up scenes. So to your point, if you have to be careful with what you're turning on and off when you run off your generator or a battery, a smart panel will actually tell you in real time when the power goes out, hey, you've got about 4 hours. If you keep running things the way you're running it right now, you have about 4 hours left on your battery, for example. And then you could actually, on the app or physically on the breaker, turn things off, and it will recast in real time and say, now, because you got rid of the 4 or 5 rooms of the house that you don't need electricity in, you turned all of those off, now you have 12 hours. And then tomorrow when the sun comes up, it recharges everything and you start the cycle all over again. So there's some really great technology. A smart panel actually makes a battery much more useful and truly turns your house into a smart home. So if you have concerns with the well pump and things of that nature, I got to make sure those things are working because it could cause other problems. A smart panel is a great marriage to a battery and a solar system. If that's everything everybody has.
So I have a question about the batteries. Do you have to replace them? Do they last the same length as the solar panels? Do they?
Yeah. Battery technology year over year is getting tremendously better. Most battery manufacturers say they'll have a 10 or a 15-year warranty to them. Over time, batteries do degrade. Most batteries in 10 years will still have about 70% of their battery retention. Do they last as long as solar panels? No, absolutely not. How long do they truly last? We're still trying to find that out. You know, battery technology right now is kind of where solar panels were in the early 2000s. Truly, we're still in the infancy with batteries. I would suggest if you had the money to do a project like this, put your money into your solar panels, which are generating electricity and generating revenue for you and offsetting your electric bill every single day, versus putting in your money into a battery that typically is just going to sit there idle for you until the power goes out.
So how much do they cost to replace? I mean, I know it's probably going to vary. They're probably going down, right? Just like batteries for electric cars.
Yeah. Good question. It kind of goes back to we're still in the infancy with batteries. We're not at the point where we have a customer saying, I purchased a battery from you and now it's in need of replacement. I guess time will tell.
Okay.
Mark, do you have anything to add to that?
Yeah, this is one of the areas where, and I don't push one over the other, but this is one of the interesting value adds on the leasing side. Leasing is across the board a 25-year warranty. If you have a battery, to Eric's point, we know that batteries are lasting about 10 to 12 years is what we're seeing right now in testing. When I've spoken to Tesla directly, they say we expect 16 years. With the leases, your battery is warranted for 25 years. So we expect you're going to have to replace a battery when you go that direction. That's covered. So 12 years from now or 16 years from now, if your battery has depleted, that's getting replaced with 12-year to 16-year newer technology. So that's one of the side values to going that direction over the other. that's it. That's it. Everybody get a chance to ask questions.
Thank you all for coming.
Thank you, guys.
Thank you.